Hi guys, welcome back. Let's look at the swapping algorithm here. So when we're swapping values in an array, and you can look at here, if we're trying to swap maybe this index 1 and index 3 here, right? Uh, Whenever we're trying to swap these two values, we cannot simply assign one value to the other, right? Because this is going to override one of the index array, right? So if we're trying to swap here a 3 and to here and this one to here, right? 1 to 3 and 3 to 1, right? We have to be able to save the value elsewhere first. So what we'll do is we create a temporary variable. We read the index 1 and save it, right? And then we assign index 1 to the value 29. So if you notice that now array 1 and array 3, index 1 and index 3 would have the same value, right? So we totally have lost 54 from the array here, right? But since we have saved it in a temporary temporary variable, we can then assign 54 back into the other index 3, right? Thereby swapping from the initial state where we have 54 and 29, and then we pretty much reverse it from 29 to 54, right? So the idea of swapping is important in array, particularly in sorting, right? So if we look into sorting algorithm, so suppose we have a bunch of numbers, right? So let's look at this, right? We have to keep swapping the bigger number to the right? So we're swapping 3 and 6 here, right? And then we're swapping 6 and 1, right? And we look at 6 and 8, and 6 is smaller than 8, so we ignore that. But if we find a number bigger than the next number, so we keep swapping it until what happens is that we're gonna have all the big numbers to the right? So the algorithm is quite simple, but it really depends on the swapping that's required, right? So this algorithm works in a lot of stages, right? So it will keep on continue and pushing all the big numbers to the right and all the small numbers to the left, right? So it keeps doing this for at least the a couple of times until we have completed all the rows and all the columns, right? So you can see that this is eventually gonna put 7 and 8 right next to each other, right? And it'll just continue until the whole process is over, right? So this is basically the sorting algorithm, and this algorithm is called the bubble sort algorithm, right? So we call it the bubble sort because it's like a bubble floating up, right? And as it flows up, it will switch or swap variables, right? That if it's bigger, it, it, it will swap values. If it's not bigger, it will just remain as it is and keep floating up, right? Okay. So you can see the implementation of bubble sort here. So we have the function prototype, we have a bunch of arrays here, and we can easily sort the arrays by 4 value. And what we need is to keep swapping it, right? If there's a bigger number, right? So we rely on a for loop here, right? For I equals to the numbers of elements, right? And we have 10 elements, so we keep swapping it 10 times in this case. Okay, so bubble sort again, so if we have a bunch of array values, then we have to, the for loop becomes much more complex in the sort function. So in so okay, so never mind, but let's look at this. So when we call bubble sort here, right, and we can look at the implementation of bubble sort. So bubble sort actually goes for I to the number of elements of array until the last one, because we don't really access the last one, right, because we are referring to the last one later, right. So and then we have the other arrays. So the first the row and the column, okay, sorry, not the row or the column, but first the number of times we look into bringing it up. So and then we continue it again and again for the number of times that we can sort it, right. So look at all the values here. So uh, the, we make this comparison to see which one is smaller, and if it's smaller then we swap it, if it's not then we just continue the for loop again, right. So if you can look at the numbers here, it's similar to the algorithm that we talk about, or it's basically the algorithm that we talk about. We start with a number, we keep comparing and move up, right, and then we continue again, and we continue again, and we continue again, right. So that's why we have two for loops here, right. So the first loop is we take a number to compare it to the next, and the next number, and the next number, and the next number, and so on, and then we continue again that step for at least the number of times as much as the numbers that we have. So if we have n numbers, we're going to loop through n times, right, times another n times, right, because we're doing it twice, right, in this case. So sorting is one of the most important algorithm that's being used a lot in computer science. The other one is searching, right. So most programmers will encounter either they need to sort them or need to search a list of data, and we rely on the for loop a lot to do this, right. So there's a couple of searching algorithm. One is the linear search algorithm. In a linear search algorithm, basically we sequentially go from one value to the next to see if that's the item that we want, right. So the idea is for all items, we compare the item with the desired item that we want, and keep on going on within that loop, right. So this is a linear search algorithm, right. It works very simple. Basically we have a declaration linear search here. This is our program, these are our numbers that's being initialized, right. So we enter a number that we're searching for, right, and then we use a linear search. In this case, the linear search would return the location or index of the particular value that we're looking for, right. So if we're looking, so the linear search function would be a simple for loop that access the array. If the key is the same, then return I, or return the value. Otherwise, return -1, which didn't return anything true, right. Okay. The other algorithm that we're going to talk about next is the binary search. So I'll continue in this next session, and we'll meet up again in a bit, right?